Hey, boys and girls, welcome to an edition of Crush Lusher Television. Mr. Irish here. This is the first video I'm going to do of this, and so any feedback you want to give me, hit me up with a text or an email saying slow down or explain this more, or I like when you did this, or I was really unclear when you did that. So here we go. This is going to be maybe a two-part video because it might be longer. This thing only lets me record 15 minutes at a time. And so here is your title right here, Volumes Given by Cross Sections number 2. I'm not going to go over the warm-up, which is finding the volume when we're given squares and rectangles of height 5. You should already be great at that. But here's one we're going to work on today. Okay? So we're going to do the same problem. Consider the region enclosed by y equals x squared and y equals x plus 2. Find the volume given by cross-sections perpendicular to the x-axis made up by semicircles, equilateral triangles, that's D right there, squares with diagonals in the xy plane, and then F circles with diameters in the xy plane. You notice how the equations, the functions are the same for all of these, okay? So, follow along as we go. Here we go. Here's my trusty new notebook. I got green one, St. Patrick's Day. Here you go. So, the problem is we have two functions. So the first one is y equals x squared. Make sure you write down everything I write down. If you are confused in any way, just pause it and go back over it, all right? So we got y equals x squared. As this thing focuses. And then we have y equals x plus 2, which is a straight line with slope of 1 and y-intercept of 2. So we're talking about all of this in here. So all of this area in here is going to be filled with, first, we're going to do semicircles. Okay? Semicircles first. So right here is going to be the base of the semicircle, then the semicircles are going to be coming out of here in a three-dimensional way. Okay? So they're going to look like this. I'm going to get a slice going. Here's a little slice. Three-dimensional right there. And so this right here is the same as this part. So this is the top minus bottom, okay? And this is the width, which is dx, which is an infinite amount of distance, so an infinite amount of these, which is a very, very small amount of distance. And so here, it's hard to fathom, but there's an infinite amount of these semicircles in there that make it a full, smooth shape. So, to find the volume of this, first you need a volume of a slice, and this is one slice right here. So the volume of any slice or any figure is usually area of the base times the height. And so in this case, the base is just the flat part, which is a semicircle. Pi r squared is the area of one circle divided by 2, because we have a semicircle, times the height. In this case, the height is right there, so it's just dx. All right? So now let's just fill in what we know. So pi, the radius, well, what is the radius? Well, we have top minus bottom right there, and that's actually the diameter. The radius is half that. So that's going to be top minus bottom divided by 2. There we go. Squared. Don't forget the other 2, because this 2 right here means we're dividing this whole circle area into 2. So don't forget that. So this is because I took the diameter divided by 2, and this is because I'm taking the circle and dividing by 2. So we need both those in there times dx. All right, so let's continue with what we're doing. So equals pi. So top minus bottom. So the top is going to be my line, and the bottom is going to be my parabola. So the top is going to be x plus 2 minus the bottom, which is x squared, divided by 2. Put that in parentheses, all squared. Dx all over 2 right there. Okay, so let's clean this up a little bit. So equals pi. So when you have a fraction like this, you can distribute the squared, so you can square the numerator and square the denominator. So that means x plus 2 minus x squared squared divided by 2 squared, which is 4, all divided by 2. All right, keep it cranking. Dx. Oop. Don't forget the dx. So dividing by 2 over 1, for example, dividing by a fraction same as multiplying by the reciprocal. So we need to flip. So we got x plus 2 minus x squared divided by 4 times 1/2 dx. So look at what I got in the denominator, 4 times 2. So my volume of one slice is pi times x plus 2 minus x squared all squared divided by 4 times 2, which is 8 dx. So that is the volume of an entire slice. But how do we get all those slices in there? So we have an infinite amount of slices between these 2 points. What are these 2 points? Pause the video and see if you can get it. Yeah, x squared equals x plus 2. You set the equations equal to each other. Looks like a quadratic, so I'm going to set it equal to 0. X squared minus x minus 2 equals 0. -1, -2. Can you see that? Yeah, you can. So what as in -1 multiplies -2, -2 and 1. X minus 2 times x plus 1 equals nothing. So my zeros would be x equals 2 and -1. Bam. So up here on my picture, I'm going to add to it. This intersection point is at x equals -1, and this intersection point is at 2. Hopefully you got that. All right, let's sum it all up now with one big integral. So the accumulation of all of those semicircle slices is the area between -1 and 2. So the volume between -1 and 2 of pi over 8. Let's take the pi right there. Times x plus 2 minus x squared dx. And then you can put this on the outside since it's a constant. So the volume equals, there we go. So just working on getting the integral set right now. We're going to use an integral calculator soon, but this is the more important part, is understanding how to get this and then what this means. All right, let's do another one. Here you go. Next one down the line. So same picture, but now we're going to have equilateral triangles coming out of the area. So we have y equals x squared, which is a parabola, and then we have y equals x plus 2 right there. And so in this area here, we're going to have an equilateral triangle coming out of here. So we have a nice little pointy top once you have those infinite amount of equilateral triangles in here. Isn't that drawing fantastic? Thank you very much. So, what do we know about an equilateral triangle? Well, first we got to label this section. Always label this section in your notes. We know that all the sides are congruent, all the angles are congruent. So 180 divided by 3 is 60. 60 plus 60 plus 60 is 180. All right, cool. So this part here and this part here are the same. So that's top minus bottom. Cool. So this side is also top minus bottom, and all the sides are top minus bottom because they're congruent in an equilateral triangle. Alrighty then. So the volume of a slice, forgot to make this three-dimensional. Ooh, got to get the drawing on. There you go, dx. Right there, that's the width. So the volume of a slice is going to be area of the face, which is a triangle, 1/2 base times height times the width, which is dx. So let's keep it going. 1/2. The base is top minus bottom. Cool. The height. Damn, what is the height? What is that? What is that? Okay. So what do we know? So let's just draw a little picture right here. So this was a 60-degree angle, so that means this is going to be 30, because 30 plus 60 plus 90 is 180. This is the top minus bottom. And this, see the top minus bottom here? If you cut that in half, you get this part right here. So this is top minus bottom divided by 2. Oh, pencil broke. Sorry. Top minus bottom divided by 2. Okay, so what is this? Because this is the same as the height. So that's what I'm trying to find. So what do I know? Well, I do know that 30, 60, 90 triangles, back to geometry class, opposite the 30 is x, the hypotenuse opposite the 90 is 2x, and then opposite the 60 is x radical 3. Bam. And so in this case, this is x opposite the 30, bam, And so that would mean my height would be whatever x is times radical 3. So in this case, it's going to be top minus bottom divided by 2 times radical 3, because that is x. Boom. And so this right here, my height is going to be top minus bottom divided by 2 times radical 3 dx. There you go. And that's the volume of one slice, volume of one of these things. Now we have an infinite amount, so therefore we have to get our integral. It's integral between -1 and 2 of, this is radical 3. I'm going to bring that right here. Then you have a half times a half, which is a fourth. And then you have top minus bottom times top minus bottom. So that's going to be x plus 2 minus x squared dx. Volume equals, put that in the calculator, and that's what you get. If you want to take this constant and put it outside, you can. There we go. Questions right now? All right, this concludes part 1. Part 2 is coming your way in a second. Great job so far.